Hello students, and welcome to our lesson on essential skills. Now, what we're going to be talking about today should feel like review, and so some of it I will actually leave for you to fill in, but I want to make sure we're all aware of a few essential facts, some basic vocabulary, and most importantly is we are going to talk about long division in this lesson. Okay, so first, basics of addition. So addition is the process of combining two or more numbers. So when we think of addition, you can think of objects sitting on a table and you count all the objects. So if there's a group of 3 objects and another group of 4 objects, you add those together, there's 7 objects total. So we're just combining numbers. It's the most basic property that we have. Vocabulary you might not be familiar with though. The numbers being added are called addends, and the result is called a sum. We might also use the word total, and there are various other words that mean to add things up, but sum and total are by far the two most common. So the word sum, I might tell you to find the sum of 1 and 2, which means to add 1 plus 2 to get 3. Or think about for total, if you are at a grocery store buying some things, the total amount of money you pay at the end is all of the individual prices added together. So we would sum up all of those prices. So the word sum and total closely linked, but the thing that might be new here is the fact that each individual object being added is called an addend. So for example, 7 plus 5 equals 12 means 7 and 5 are the addends and 12 is the sum. So now what I want you to do in this table below is practice adding numbers together. So for example, the first box here, right here, is going to be the combination of what's to the left and what's above. So we would add the number on the left to the number above. 1 plus 1 is going to give us 2. So I would just write 2 in that box. Then for the next box over, so this box right here, I'm going to be adding the 2 on top with the 1 that's on the left. So 1 plus 2 gives me 3. 1 plus 3 gives me 4. 1 plus 4 gives me 5. And I'm not going to fill this all the way in. This is just for you to make sure you're practicing. In class, it drives me crazy when students pull out their calculator to add single digit numbers. Okay, you need to be able to tell me what is 5 plus 1. Hey, that's 6. You need to be able to tell me that right away. And it is just a matter of practice. Okay, so you should be able to fill in this entire grid by yourself without using a calculator at all. So I'll finish off the first row here. But then you should be able to work all the way down to the very bottom box will be 10 plus 10, so 20 will end up in the bottom there. All right, so that's there for you to practice. Moving on, we have multiplication. Multiplication is repeated addition. So we just talked about addition. Multiplication is just adding something over and over again. The numbers being multiplied together are called factors. That's an important word that's going to come up quite a few times in this course. Okay, factors. And the result is called the product. So the multiplication of two factors gives you a product. So for example, 4 times 6 equals 24. 4 and 6 are the factors, and 24 is the product. All right, and then again, there is a grid here for you to fill in. Again, it drives me crazy in class when students cannot multiply single digit numbers. We have to do it so often that if you are pulling out your calculator every time, it is going to take you forever to get through this course. And these numbers show up all the time in real life. So you really need to be able to do quick calculations. So the grid works the same way. We're just multiplying instead of adding. So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. You can go on all the way to the side. Just as an example of what it looks like if you do a middle box, if I want this box right here in the center, I'm going to be multiplying the number on the left, which in this case is 6, times the number above. So 6 times 6 would give me 36 in that box. Okay, so you're just lining up the numbers. This should go all the way down to 10 times 10 at the end is 100. Absolutely essential that you can fill in all of these multiples on your own from no work being shown. So when you're doing 8 times 7, so for this box over here, when you're doing, in this case, actually 8 times 6, you should know that that is 48 without having to actually multiply anything out. Okay, the way we get there is we do 8 plus 8 plus 8 plus 8 plus 8 plus 8 6 times. That's why we call it repeated addition. But you need to know all of the multiples of single digit numbers off the top of your head. Okay, it will make your entire life easier, but especially it will make this course easier. All right, so there you go for multiplication. That is a memorizing activity. Please memorize all of the boxes that go on this first page. All right, now things we are actually going to work through. Long division. Okay, long division answers the question, how many times does one number, okay, and that number is called the divisor. So how many times does the divisor go into another number, and that other number is called the dividend. Okay, so we're trying to figure out how many of one number go into another number, but we also want to know what's left over if there is anything left over. So a couple steps. First step is we are going to divide. Okay, we want to know how many times does the divisor fit into the first digits. Okay, so we're not dividing the whole number in that first step, just the first digit. Then we will multiply whatever we got from step 1 by the divisor. So we'll multiply the divisor by that quotient we just got. Then we will subtract that from down below. So subtract to find what is left over. We'll bring down, okay, bring down or drop the next digit, and then we'll repeat. Okay, so we're going to actually work through a couple of these. First one we have is 48 divided by 3. 48 is what we are dividing. So we call that the dividend. And 3 is what we're dividing by. We call this the divisor. So we are dividing 48 by 3, and we're going to try to find the quotient, which is the result. The way we set this up, we put the dividend inside. So 48 goes inside this division box, and the divisor goes on the outside. All right, so now step 1 is divide. So we want to know how many times does 3 go into this first digit, which is 4. Okay, 3 goes into 4 one time. So I'm going to write a 1 up above. Then step 2 is to multiply. I'm going to multiply what I just wrote, that 1, by the divisor. So I'm multiplying 1 by 3. Right? When I do that, I get 3. And what you do then is you subtract 4 minus 3 in this case gives me 1. All right, then I bring down the next digit. Oops, accidentally deleted my 1 there. Then I'm going to bring down the next digit, which is this 8. It drops down to right here. And then we repeat the process. So now we're asking ourselves, how many times does 3 divide 1? Well, it doesn't. So we move on. Instead, we ask, how many times does 3 divide this whole thing? 18. 3 divides 18 6 times. So I'm going to write a 6 up top. And then I'm going to multiply. I'm going to do 6 times 3 and write that result down below and subtract. So down below, I'm going to write 6 times 3 is 18. I'll subtract, and that leaves me with 0. And then there's nothing to drop down. All right, so the only things we don't have labeled here yet, we already know 48 is the dividend and 3 is the divisor. 16 up here on top is called the quotient. And 0 down here at the bottom is the remainder. Okay, so we have quotient, remainder, dividend, divisor. All right, number 2, we have 845 divided by 7. 845 is our dividend, 7 is our divisor. So I'm going to write 845 inside the box and 7 on the outside. And then I'm going to ask myself, how many times does 7 divide this first digit, which is 8? 7 only goes into 8 one time. So I'm going to write a 1 on top. And then I'm going to multiply 1 times 7. 1 times 7 is 7. I subtract that from down below. 8 minus 7 gives me 1. And then I drop down the next digit, which is a 4. All right, so now I start over. I ask myself, how many times does 7 divide 14? 7 goes into 14 2 times. So I'm going to write a 2 on top. And then I'm going to multiply. 2 times 7 is 14. So I'm going to write 14 down below, and I'm going to subtract. When I do the subtraction, I get 0. And then I'm going to drop down the next digit, which is a 5. Now, because there's a 0 in front of the 5, I can essentially just ignore the 0. But I'm going to ask myself, just like before, how many times does 7, the divisor, go into whatever is written down here? So 7 goes into 5 0 times. All right, since 7 goes into 5 0 times, meaning it does not go into 5, I'm going to write a 0 up top. And then when I do 0 times 7, that is 0. So I'm going to subtract 0 down below. And that gives me a result of just 5. So now in the future, we will find decimals that allow us to keep dividing. But for our current purposes, we want to find the actual remainder, which is that 5 down below. So we have that 845 divided by 7 gives me 120 as a quotient and 5 as a remainder. All right, so we can then summarize this and we can write out what we actually got. We can say that 845 divided by 7 is equal to 120, and we use an R with a colon and then the remainder. So 120 remainder 5. Again, in the future, we will turn that remainder of 5 into a decimal, but for now, we actually want to know the remainder. And I'll show you why on number 3 right now. It says if 845 tickets are sold and each booklet holds 7 tickets, how many full booklets and how many left over will we have? So notice it's the exact same numbers we just used. Okay, we already know that 845 divided by 7 is equal to 120 with a remainder of 5. So the number of full booklets that we can fill is the quotient, which in this case is the 120. The remainder is exactly what it sounds like. That's the 5 that we had left over. And so our interpretation now is just a sentence that states what we uncovered. Okay. We can make, so in this case, it says if 845 tickets are sold and each booklet holds 7, how many full booklets and how many left over? So we can say 120 full booklets of 7 tickets each with 5 tickets left over. All right, so we can fill 120 booklets, but we will have 5 tickets that are just left over on the side, and that is our remainder. Okay, one more. We have 23 participants, and each group needs 3. How many full groups and how many participants are left out? So if we divide 23 by 3 using long division, 3 does not go into 2, so I skip that first digit. And then I ask how many times does 3 go into 23? 7 times is the answer. 7 times 3 is 21. So then I subtract 21. 23 minus 21 gives me 2. And because we have no more digits to drop down, we're done. 23 divided by 3 is 7 with a remainder of 2. So that means that we can make 7 full groups and we will have 2 people left out. Okay, 7 full groups, 2 people left out. So the interpretation is just that spelled out. We can form 7 groups of 3 with 2 students left over. Or not students in this case, with 2 participants left over. Okay, so the point of long division, if we don't want decimals, is to find that remainder. And we are going to have various points throughout mathematics where this remainder is actually very important to us. So until we talk about decimals, this is how we will get remainders and quotients. All right, a couple more topics. We want to go through real quick exponential and expanded notation. So we have these things called exponents that make our lives a little bit more convenient. Essentially, when we have a whole bunch of the same number being multiplied, we want to write it in a much quicker way. So what we have here is 2 forms. We have the left where it says a to the power n. This is exponential form, where we are using an exponent on a base of a. So right here we have 2 pieces. Okay, a is the base and n is the exponent. But the entire thing is called exponential form because we have an exponent, so exponential form. The right side, okay, everything that is over here, all these n factors, This is called expanded form. And the way it works is however big your exponent is, you multiply a by itself that many times. So in this case, we have a to the power n. So we have a times a times a times a times a, where there are n a's. Makes a lot more sense when you see it with a real example. So for number 5, we want to write 2 to the power 5 in expanded form. This is equal to 2 times 2 times 2 times 2 times 2, where there are 5 2's. Okay, 5 2's. Let me write 2's as a word. TWOS. Okay, 5 2's. For number 6, we want to write 10 to the power 3 in expanded form. This can also be called 10 cubed. Okay, 10 to the power 3 is 10 times 10 times 10, where there is 3 10's. Okay, so exponents are just convenient ways to write out repeated multiplication by the same number. And this is going to be very important to us when we get to factoring numbers and writing them in their prime factorization soon in a future lesson. We are going to need exponential form to make those prime factorizations look nice and simple. All right, now a couple things just to wind out. Remember, this lesson is all about essential skills, really things that I need you to remember all the time. And so the 2 other things I need you to remember all the time are perfect squares and perfect cubes that come up a lot. So a perfect square is the product of a whole number with itself. Okay, and so you can see in the table here, if our number is, let's say, 1, then the exponential form for it squared would be 1 to the power 2. Expanded form, which is what we just did, would be 1 times 1, where there's 2 of those 1's. And the actual value is just what you get when you multiply it. So 1 times 1 is just 1. So what that tells us is that 1 squared is 1. For the next one, 2 is our number. 2 squared is the same thing as 2 times 2. And 2 times 2 is equal to 4. Then we have 3 squared is 9. And the idea here is that I want you to memorize these. Okay, all the way up to 15. These are numbers that come up a lot in mathematics, and it'll make your life a little bit easier if you can just commit these to memory. At the very least, you absolutely have to know the first 10 because they're on that multiplication grid I showed you earlier. But really, you should know all the way to 15. All right, next one, 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. The way I remember those two is notice that the digits are just switched. 69 and 96 just replace each other. And the last one, 15 squared is 225. And the way I remember that one is that it's a very convenient weight for if you're in the weight room ever and you are lifting plates that weigh 45 pounds each. 225 pounds is 245 pounds on each side of a 45-pound bar. So it's just a number that shows up a lot if you are ever in the gym lifting heavy weights. All right, some perfect cubes now that I want you to remember. Same idea, just numbers that I would like you to memorize because they're going to come up a lot. So in this case, we're taking a number and we're cubing it, meaning raising it to the power 3. So 1 cubed is 1 times 1 times 1, and that still just equals 1. 2 cubed is 2 times 2 times 2, that is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. And 7 cubed is 343. All right, please practice your addition and your multiplication. Please remember exponential notation and these perfect cubes and squares. And most importantly, please make sure that you can do long division because we need this process for quite a few things in mathematics. And it's not that hard as long as you get the steps down. We're just doing the same 4 or 5 steps over and over again. And it never really gets harder than that. The numbers might get bigger, but the process stays exactly the same. All right, thank you for joining me on this one, guys, and I will see you in the next lesson.